Welcome back to The Explainer. So we're jumping right into something literally every programmer on the planet has to deal with at some point, the dreaded application crash. You know the feeling, right? You're using an app, everything's humming along just fine, and then bam, the whole thing just shuts down because of one tiny, unexpected hiccup behind the scenes. It's incredibly frustrating. But here's the thing. Professional, top-tier applications, they actually detect these problems, catch them safely, and just keep on running like nothing even happened. It's kind of like magic, but really, it's just professional error handling. And today, we're going to completely demystify exactly how that works using try, catch, and finally logic.
Okay, let's look at our roadmap for conquering these code crashes. First, when apps crash. Second, syntax versus runtime errors. Third, the try-catch safety net. Fourth, resource cleanup with finally. Fifth, catching and logging errors. And finally, number 6, best practices to remember.
Section 1. When applications suddenly crash. Now I want you to actually picture the scenario for a second. What happens when a banking app fails right in the middle of a transfer? You're on your phone, you just typed in your whole month's rent to send to your landlord, you hit send, and right as it's processing, your Wi-Fi totally drops. The server loses connection. If the app just outright crashes with zero explanation, you are gonna panic. I mean, did the money leave the account? Am I gonna get charged twice? It is an absolute nightmare for the user experience, and honestly, it completely shatters trust in that software.
But let's walk through that exact same timeline in a professional, well-engineered app. Step 1. The user hits transfer. Step 2. The server loses connection unexpectedly. But Step 3. Instead of panicking and shutting down, a professional app detects the issue, protects your data, and gracefully pops up a friendly message like, "Hey, connection lost. Please try again." The app stays completely stable. That graceful recovery is exactly why professional systems never go without proper exception handling.
Section 2. Syntax versus runtime errors.
To stop these crashes, we really need to know what we're up against. So, on the left, we have syntax errors. Think of these like simple spelling or grammar mistakes in your code. You forgot a bracket, you misspelled a command. The good news here is your code editor usually catches these before the program even runs, with those little red squiggly lines. But over on the right, we have runtime errors. These are much trickier. The code looks perfect, it starts running just fine, but then it hits an unexpected situation. It's literally like driving a perfectly good car down a smooth road and hitting an invisible pothole. The car is fine, but the environment caused a shock. In code, this might be trying to divide by 0, or trying to open a file that someone deleted. That unexpected pothole is what we call an exception.
Section 3. The try-catch safety net.
So how do places like Google or Amazon survive those invisible potholes? It starts with the try block. This is where you put your risky code. I always picture this like a circus acrobat stepping up to attempt a really dangerous high-wire trick. The program enters this block and simply tries to pull off the maneuver. If the environment is perfect and no error happens, awesome, the trick succeeds and the show goes on without a hitch.
But what if the acrobat slips? Well, that's exactly where the catch block comes in. Or if you're writing in Python, it's called the except block. This is the literal safety net placed right under our acrobat. It is a total lifesaver. If an exception triggers up in the try block, the execution immediately drops down into this catch block. The error gets safely scooped up, meaning your entire application doesn't just plummet to the ground. You can show a proper message, recover, and keep the app running.
Section 4. Resource cleanup with finally.
Okay, so the trick is over. The acrobat either nailed it or they fell into the net. But what about the stage? Someone has to clean it up. Enter the finally block. Think of this as your ultra-reliable stage crew. The finally block always runs, no matter what just happened. Trick succeeded, finally runs. Trick failed, finally runs. This is incredibly important because this is where you clean up your resources. You close files, you release memory, you sever database connections. If you skip this, those open connections just pile up in the background until your server totally runs out of memory and crashes anyway. So, the finally block keeps things perfectly clean and ready for the next request.
Section 5. Catching and logging errors. Let's talk about the big leagues now. Think of a massive online store dealing with bad coupons, declined cards, or missing inventory. How you catch those specific errors is a big deal. A super common rookie mistake is throwing out this massive generic net that blindly catches everything. It's a debugging nightmare because you know something broke, but you have no clue what or why. The pro move? Catch specific exceptions. Catch a value error for the bad coupon. Catch a connection error for the payment timeout. By handling these separately, you're not just guessing anymore. You can actually fix the specific problem.
And I need to give you a massive warning here. Please, never use empty catch blocks.
They are so dangerous. If you catch an error and do absolutely nothing with it, the program just silently swallows the problem and pretends everything is fine. You won't even know something is broken until users start complaining on Twitter or your whole database is corrupted. Always log the error professionally, or at least show a message. Never just ignore it.
Speaking of messages, writing good ones is a true sign of a pro. I mean, look at this. Imagine showing an obscure error 404 to a non-technical user. That means absolutely nothing to them. They're just going to close your app. But if you show something like user profile not found, please check the ID, suddenly they know exactly what's wrong and how to fix it themselves. It totally transforms the user experience and saves you a ton of troubleshooting headaches later.
Section 6. Best practices to remember.
All right, let's pull all this together into a quick checklist. Remember, bugs and errors are totally normal. It's how you handle them that counts. Number 1, never ignore errors. Silent failures are the absolute worst. Number 2, use specific exceptions so you actually know what's breaking. Number 3, write meaningful messages that actually help your users. Number 4, always use finally blocks to clean up memory and resources. And number 5, log those errors professionally so you can keep an eye on your app's health. You're engineering for the real world here, potholes and all.
So, I want to leave you with this. Which programming error confuses you the most right now? And how are you going to build your safety net to catch it? Seriously, think about your own code. Where are your acrobats operating without a net right now? Because now that you know the logic behind try, catch, and finally, you have the exact tools you need to turn a fragile, buggy app into rock-solid software. Thanks so much for joining me on the Explainer today. Get out there, build those safety nets, and I will catch you in the next one.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are coming soon.